Hello there, this is Mr. Casey from Penrith Howell School in Swansea, one of our Colin Cymru sessions. Today we're going to be looking at solving linear equations. So this is an intermediate maths and numeracy topic. It will certainly appear in both exams. Okay, so we're going to be looking at 4 sessions between myself and Mrs. Dixon. So I'm going to be doing a session on solving linear equations today. My next session is going to be solving simultaneous equations, and then Miss Dixon will look at a couple of percentage topics. And then the final session will be myself and Mrs. Dixon, just recapping on the sessions that we've been through. Okay, so here we can see the intermediate scheme of work for WJUC. We can see straight away that linear equations appears on both the GCSE maths and the GCSE numeracy. So it is quite a common topic, and it is also linked to quite a few other topics. So quite often you have to sort of solve equations when we do things like trigonometry, Pythagoras. Those sorts of topics will involve an element of solving equations. So we're going to look at a few sort of algebra basics before we start, just to get into it. So what we're going to do is have a go at those questions. It might be an idea now to pause the video just for a minute to have a go at them, and then I'll come back in and just sort of cover the answers. Okay, so let's have a quick look. So looking at the first one, we're collecting terms. So we're looking at x values and we're looking at y values this time. So they're all positives in this question, so it's quite a nice one. So look at the y's first, 3 y's there and there's 4 y's there. So collectively that makes 7y and 4x, but remember x on its own is the same as 1x. So we're adding these together, so we've got 4x and 1x, which gives us 5x. If I was to be super fussy, I put the x's before the y's because it should be in alphabetical order, but that's absolutely fine as an answer, and that would get full marks. Look at the next question. We've got g's and we've got d's, but there's some minuses here, so we need to be careful. So we get 8g, add 2g, which is 10g. That's okay, that's all positive. But I've got -6, -5. Now, don't be confused now by the sort of minus, and a minus makes a plus. So think about it as you started on -6 on the number line, you're taking away 5, and that gives us -11d. Okay, the next ones are expanding brackets. So I'm going to do 3 times 5m, which is 15m, and 3 times 7, which is a positive 21. Be careful, a lot of people when they expand brackets, they'll add. It's all about multiplying. So the term outside is multiplied by what's inside the brackets. Next one is a bit more going on because there's 2 brackets. So I'm going to multiply out the first set of brackets as like its own question, if you like. So 4 4s are 16, so that's going to be 16x. 4 times 8 is 32, so I'm adding on 32. Then I'm going to expand the next set of brackets. 5 times 3 is 15, so 15x. And then 5 times -7 is -35. So there's a negative there because we are multiplying a positive value of 5 by a negative value of 7. So that gives us -35. But we can simplify that by having 16x and 15x gives us 31x. And we've got the positive 32, take away 35, that's going to be a negative term of -3. Okay, so let's have a look at what we're doing today. So what we're going to try and cover is the sort of principle of how balance works in equations. So when we look at basic equations, it's all about balance. And whenever we do one side, we must do the other side. You may have heard your maths teacher saying that before. We're going to be solving 2-step equations. Then we'll look at some equations in brackets. Then with unknowns both sides, and what I mean by that is it could have x both sides or y both sides or whatever letter we use in the question. And then we're going to look at some GCSE questions to finish off. Okay, so think of an equation as a set of balance scales. Okay, so as you can see on these balance scales here, you've got x on one side and you've got 2 little blocks, and you've got 6 blocks on the other side. So if you like, I mean, the answer may be fairly obvious to some of you, what the value of x is. But in this question, we're trying to find out what x is. So if you like, x is a mystery weight. Now, we always want to try and get x on its own. Of course, we can use any other letter, but for this question, it's an x. So you want to get x on its own. So what we really want to do is remove those two blocks that have just disappeared. So those two blocks are gone. Now, the problem with that is if these were balanced scales, suddenly by removing those two blocks, it would make the other side of the scales heavier. And you get the effect that you can see on the screen now. So these 6 blocks are pushed down, and they're pulling down on the weight, and the balance no longer remains because one side is heavier than the other. Now, what we can also do to sort that out is take 2 blocks off the right-hand side as you're looking at the screen, and that will then restore the balance, and x is the same as whatever's left on the other side. And in this case, there's 4 blocks, so we would say x is equal to 4. Now, that's a really fundamental rule, really. Whatever we do one side, we must do to the other. Otherwise the balance and the equation will be incorrect. So let's look at the sort of basics. So we've got 4 questions here, and I've chosen these 4. They're really basic questions. So if I was to start doing equations with maybe a younger class, these are the sort of questions I start with. And if we look in here, I'd like to think a lot of you will look at these and know the answers. Some may not, but that's okay. If there's a +7 there, I want to get rid of that +7, so I'm going to take away 7. But remember, I must take away 7 from both sides. So 7 take away 7, that's gone. I'm only left with A, and 15 take away 7 is 8. So the value of A is equal to 8. And these principles that we're covering with these 4 sort of quick examples, we're going to be use these throughout the lesson today. Okay, so next one, there's a -6. So I'm adding on 6 that side, adding on 6 that side, and I'm getting rid of the minus because -6 add 6 is 0, so there's only y left there, and then 3 add 6 is 9, so the value of y is 9. My 9 has gone a bit weird there, but we can live with that. It looks a little bit like a G. The third one, we've got 7h equals 28, so 7 multiplied by h is 28. Now the opposite of multiply is divide, so what I'm going to do is I'm going to divide both sides by 7. So what I get is 7 divided by 7, which is 1. So I write 1h, but I'm not going to bother writing 1h. I'm just going to write h. And then 28 divided by 7 is 4. But again, what's important is whatever I do one side, I do the other. And then the last question is k divided by 4 is equal to 12. So I'm going to multiply both sides by 4. So times both sides by 4. What I end up with is 4k over 4, very similar to what I had on question 3. The 4s will cancel each other out, and then I'll have 1k or just k, and whatever 12 times 4 is, which of course is 48. So those are the sort of the main principles we're going to be looking at today: adding on both sides, subtracting both sides, dividing both sides, and multiplying both sides. Now, just really quickly, of course, I can check any one of these answers. So I'll look at this question 1, and I'll check this answer. So I think the answer is 8. So A is equal to 8. So if I think A is 8, I'll do 8 add 7, and it should equal 15. So again, that balance is there, and it's the same both sides. Okay, so let's look at a couple of questions. So these could be standalone questions in a maths paper. So we call these 2-step equations because we solve them pretty much in 2 steps. So we've got 6p plus 5 equals 29. So the first thing I want to do is get rid of this 5, and my ultimate aim is to get p on its own. So I'm going to take away 5 from this side. I'm also going to take away 5 from this side. Remember, whatever I do both sides, and that leaves me with 6p, and I've got 29 take away 5, which is 24. So that's certainly my first step of my 2-step equation. Now, I don't want 6p as part of my answer. I just want p. So I'm going to divide this side by 6, divide by 6, and the value of p is 24 divided by 6, which is 4. Now we have to be really conscious now that I've got a nice whole number 4 there. That's great. It works out really nicely. That's not always going to be the case. Quite often you're going to get a decimal. You could even possibly have a negative number as your answer. So we got -3 here in this equation. So I got 5d minus 3 equals -13. That's not very nice. We'll deal with that in a second. So I want to get rid of this -3. So I'm going to do the opposite. I'm going to add on 3, but I must add on 3 both sides. So that gives me a value of 5d. So think about -3 on the number line. If you add it on 3, you move to the right on the number line and you'd end up on -10. And very similar to question 1, I now need to divide. The coefficient of d is 5. I want to get rid of that by dividing by 5. So d is now on its own, and -10 divided by 5 gives us a value of -2. So like I mentioned earlier, you will get some negative answers. Now this one looks a bit different. Okay, it looks a bit different. There's a +9 there. H divided by 6, that means divide, of course. Add 9 equals 12. But I'm looking at this +9. I want to get rid of that. So I'm going to take away 9 both sides. So I'm trying to get H on its own. That's what I'm aiming for. So H over 6 equals 12. Take away 9, which of course is 3. And what I've now got is H divided by 6 equals 3. So I'm going to times by 6 here, times by 6 here. So the value of H is 3 times 6, which is 18. Okay, so we'll pause the video there. Pause the video here is probably the best bet. Have a go at those 3 on paper, and I'll come back in and we'll go through some answers. Okay, so let's have a quick look. So you should have had to go at those 3. I might do these a little bit quicker because you should have your answers on paper. So we'll go through these a little bit quicker. So I'm going to take away 7, and that gives me 5m equals 20. And then I'm going to divide by 5. The value of m is equal to 4. So I still did my 2 steps. I still did my my subtraction first, and then my dividing. This one is a -8, so I'm going to add 8 to both sides, add 8 to both sides. So 6c is equal to 36. Then I divide by the coefficient, which is 6, divide by 6. The value of c is 6, because 36 divided by 6, of course, is 6. And we should know 36 is a square number. M divided by 10, -4 equals 4. So I'm going to add on 4 here. I want to get rid of that -4. I want to get m on its own. That's the plan. So m divided by 10. I need to do 4 add 4 here, which is 8. So I got something divided by 10 is 8. So I need to be timesing by 10 really to get rid of this sort of what looks like a fraction. Times by 10 both sides. So I've now got m on its own, and the value of m is 80. That seems like a really big answer to me. M equals 80. I'm not confident I've done that right. So what I'm going to do is I'm going to put that that m equals 80 back into the original equation. So I'm going to think to myself, 80 divided by 10 is 8. That makes sense. 80 divided by 10 is 8. Take away 4 is 4. Yeah, so I'm happy now that this 80 fits in with the equation. So I've done a little substitution just to check that works. Okay, the next type we're going to look at are equations with brackets. Now, there are a couple of ways of doing these. We can sort of divide both sides first, but I think the most preferred method is to expand the brackets. So we had a little bit of practice of that earlier. So I'll get rid of these brackets. I'll do 5 times h is 5h. Remember, it's all about multiplying. 5 times -7 is -35. And that's still equal to 20. So I did mention earlier, whatever we do the same both sides, but we haven't really changed the value of the left-hand side. All I've done is write it in a different way. So it's -35 now. So I can add on 35 to the left-hand side, add 35 to the right-hand side, and that gives me 5h equals 55. I'm going to divide both sides by 5, and the value of h is 11. So really similar to our previous question. The main difference being is I have to expand the brackets first, then I can do my adding both sides, then my dividing. Okay, the next one, I'll expand the brackets again. So 7 times 4x is 28x, plus 7 times 6, which is 42. And again, that's equal to 56. Now this time I'm going to take away 42 from both sides, and I really can't say that enough. If you get bored of me saying that, I apologize, but whatever we do, we must do both sides. So I've got 28x is equal to whatever 56 take away 42 is, and that's going to be 14. Now, there's a really good chance here of making a mistake because we're going to divide both sides by 28. And there's a real big temptation, and it's a really common answer, that 14 divided by 28 is 2. It's not. You've got to be careful. If it was 28 over 14, it would be 2. But in this case, 14 over 28 becomes 0.5. Or, of course, we could write a half. A half would be fine. Okay, so you've got to be careful when dividing numbers when the denominator is a larger number. Okay, so number 3, there's a bit more going on here. We've got these brackets to expand, so I'll do that. But there's a 6 on the bottom as well. So I'm going to try and do this in one step. So I'm going to times both sides by 6. So I'm really going to do 18 times 6 to get rid of the 6 on the bottom. And then, of course, I have to times both sides. But at the same time, because I haven't got a lot of space on the screen, I think I'll expand the bracket. So 3 times 5a is 15a. 3 times 1 is 3. And remember, I've times this 18 by 6 already, so that gives me 108. And then that's kind of my starting point of my two-step equation. Take away 3 from both sides, take away 3, so 15a is 108, take away 3, which is 105. And then divide both sides by 15, divide by 15, 105 divided by 15 is 7. So a little bit trickier, but there's nothing really on there that we haven't covered on our basic rules. Okay, so there's nothing really there that we haven't sort of come across. Okay, so if I move on to the next question now. Okay, so a few brackets again. Might be worth you pausing the video at this stage just to have a go at those 3, and I'll come back in to go through the answers. Okay, bear with me for 1 second. My PowerPoint's playing up for a second, so I just need to go back into that, and then we can carry on. Okay, great. Okay, so let's just go through these. So I'm going to expand the brackets. Let me just get my pen back. So that becomes 8 times 3 is 24e minus, and this time we're going to be doing 8 times 12, which is 96. And then this 24 is over this side. We haven't really done anything with that yet. I'm going to take away 96. Now, sorry, my apologies. We're going to add on 96. I'm going to add it both sides. So of course, I did say take away by mistake there, but because it's a minus 96 in the question, I'm going to do the opposite of that. So I'm going to add on 96. So 24e. So 24 add 96 gives me 120. That's a pretty big number. But I'm going to divide by the coefficient again, divide by 24. So e equals, now I know 120 divided by 12 is 10. So 120 divided by 24 is 5. So the value of e is 5. Just want to expand again. So that becomes 48t plus 12. And that is equal to minus 12. So I'm going to take away 12 both sides. Take away 12. Now think about this minus 12. And I'm going to take away another 12. So again, there's an opportunity to make a mistake with the negatives here. You've got to be careful. That is going to be minus 24. And when I divide both sides by 48, divide both sides by 48, the value of t is minus 24 divided by 48. So that's minus 0.5. Or of course, I could write minus a half. And then the last one of the brackets, which you should have had a go at, is we're dividing by 5. So I'm going to get rid of that by timesing by 5, times by 5. But I'm kind of going to expand the brackets at the same time. So I'm getting rid of this 5 on the bottom. I'll expand the brackets to get 2k minus 18. And that is equal to minus 8 times 5, which is minus 40. Now, I want to get rid of this minus 18. So I add on 18 both sides, add 18, and then I've got 2k equals minus 40, add 18, which is minus 22. And then divide by 2, and very quickly run out of space with this one. K is minus 11. Okay, so the types of questions we've looked at with the two-step equations and also with the equations with brackets, we've only had one x. Okay, we've only had one value of x. What we're going to see on the next screen is equations with unknowns both sides. So this is the thing we're talking about. So what you can see in the first question is there's a 6w and a 4w, and this does confuse people. People think, you know, they get left with a w and a number, and it does cause some issues. But the main thing you want to do is decide what side do I want my w's on. That sounds weird, I know, but what side do I want my letters on, and what side do I want my my normal numbers on? Now, I always when I teach this in class, or you know, in my school, there's 6 w's there, there's 4 there, so there's more w's on the left hand side here. That doesn't always happen, but there's more w's here. So I want to get rid of 4 w's from this side. I want to take away 4w, but of course, whatever I do one side, I must do the other side. So if I got 6w, take away 4w, that gives me 2w. 4w, take away 4w, they're gone now, and this 14 remains. So from what looks quite complicated, straight away, it's now quite a simple equation. All I've got to do is divide by 2, and I'm going to do that both sides. The value of w is 7. Okay, so the next one, I'm going to make the same decision. I'm looking now, there's 6y there, 2y there, so there's definitely no more y's on the left hand side. So think of this as the left hand side and this is the right hand side. So I'm going to take away 2y from that side, and I'm going to take away 2y from that side, and that leaves me with 4y. I mean, this plus 3 is still there. I haven't done anything with that yet. But this minus 5, now you've got to be careful to leave this minus here. Okay, I can't just write this as 5 because that minus 5 is that minus is included in that term. But what I can now do is, because there's a plus 3 there, I can take away 3 both sides, take away 3, and that gives me 4w equals minus 8. So I divide both sides by 4, divide by 4, the value of y is minus 8 divided by 4, which is minus 2. And the last one, now we've got some brackets here in the mix. So I'm looking at this now. It looks like there's more d's on the left-hand side, but I haven't expanded the brackets yet, so you've got to be careful. So I'm going to write 7d plus 3, and then I can expand the brackets. 4 times 3 is 12, and 4 times 2 is 8. So I've expanded the brackets now. Now, actually, there's more d's on the right-hand side. Remember, this being the left, this being the right. There's more d's here. Now, you could take away 12d from both sides. That wouldn't be the end of the world. But if you did that, you'd have a negative d term, and you might have to divide by a negative at the end. But it would still work out as long as your maths was right. But I think what I would prefer to do is get rid of the 7d. It doesn't really matter what side we have the d on. So I'm going to take away 7d both sides. This 3 hasn't changed, that's still there. 12d take away 7d gives me 5d, and that plus 8 is still there. So it looks a bit odd. It's not really what we're used to with the sort of d being in the middle there, but it should still work out. I'm going to take away 8 there, take away 8 there, and that gives me 3 take away 8 is minus 5 equals 5d. Now, I got 5 times d, so I'm going to divide by 5, divide by 5. I can cheat a little bit now. If I want, I can put the d over the other side because that's where we'd normally see the answer. And then minus 5 divided by 5 is minus 1. And again, if you wrote that the other way round, minus 1 equals d, that would be absolutely fine. That wouldn't be an issue. Okay, so 3 of those for you to have a go at. So please have a go at those 3, and then we'll have a look at some exam questions. Okay, so let's take a look. Again, I'm going to try and go through these a little bit quicker because I'm conscious of time, and I think it would be beneficial to do a few of the exam questions. So I'm going to take away 2b from both sides, take away 2b, take away 2b, and that's going to give me 3b plus 6 equals minus 3. Remember, you've got to keep the minus there. I'm going to take away 6 from both sides, take away 6, and that gives me 3b equals minus 9. I'm trying really careful not to make my b's look like 6's, so you've got to be careful with that. Remember, the person marking your paper probably doesn't know what your handwriting is like, so you've got to be careful. Divide by 3, divide by 3. The value of b is minus 9 divided by 3, which is minus 3. This one. So I've got a 5y and just a y. Remember, y on its own is 1y, so I'm going to take away y or take away 1y both sides. That gives me 4y minus 2 equals minus 14. There's a lot of minuses in this question. But I'm going to add on 2 both sides, add on 2, and that gives me 4y equals minus 12. And then we divide by 4 both sides, divide by 4, divide by 4, y equals minus 3. Same as the previous answer, so that can happen sometimes. And then this one, I'm going to expand the brackets just to sort of see where we are. 2 times 4 is 8, so that's 8k. And then 2 times minus 9 is minus 18, okay? Now, there's 9k's on this side now, and there's 8 here. So I think we're just going to take away the 8k from this side and from this side. Remember, always the same both sides. That leaves me with 1k. I'll write that as k. Take away 3 equals minus 18. So because I've only got k there, minus 3 is minus 18, all I need to do as my final step is add on 3 both sides. So the value of k is minus 15. And of course, if that said 5k or 10k, I'd have to divide at the end. But for this question, I don't need to, because I'm left with a single value of k at the end. Okay, so let's take a look at some GCSE questions. Again, it may be worth you sort of having to go at these yourself. So when we look at each question, maybe just sort of pause the video. I'll sort of pause for a minute, but pause it on your screen. Try the question on a bit of paper, and then I'll come back in and I'll go through the answers. Okay, so here's our first one, and this is just not really problem solving. This is, pasted straight from an exam paper, and it's the sort of thing we sort of come across. Maybe the numbers are a little bit bigger, but the principle of the question is the same. So pause the video now if you like, have a quick go, and I'll come back in and run through it. Okay, so we've got a 8x this side minus 77 and a 2x minus 5. I think I want to get rid of the 2x from both sides. I think that'd be my first step. There are other things you can do first, but that'd be, I think, my first step. And that would leave me with 6x minus 77 equals minus 5. That's what I would do as my first step. And bearing in mind, a lot of these questions will be on non-calculator paper, so you're going to have to sort of work out the negatives and the addition and subtraction without a calculator. I'm now going to get rid of this minus 77, so I think I'm going to add on 77 to get rid of that. But of course, whatever I do, I'm going to do both sides. So I've got 6x here. Now, minus 5 adds 77. I don't really like the sound of that. That sounds a bit confusing. But if I do 77 take away 5, I'm going to get the same answer, which is 72. And then I'm going to divide both sides by 6, divide by 6. The value of x is 12. So that's my final solution. Okay, so the second GCSE question, it's in 3 parts. Some equations easier than others. So again, I'll give you a minute just to have a quick look at that, and then we'll go through them together. Okay, so the first one, we've got this 5 on the bottom. So I times both sides by 5. They haven't given us a lot of space for workings here, but that would give me 8x equals 60 times 5, which is 300. And then we're going to divide both sides by 8. Now, I don't think 8 goes into 300 very nicely. I'll just pop the answer here at the side. So we know 300 divided by 2 is 150, divide again is 75, then divide again, it's going to be a decimal, isn't it? So it's going to be 37.5. If we half again, that's what we're going to get to. This one is a bit of an odd one because X is on the bottom. It's a little bit different. So this is why I chose this when I did the lesson. So what you're kind of doing this time, it's a bit of a strange one. What you're kind of doing is multiplying both sides by X to get rid of the X on the bottom. So if we do that, we end up with 3 equals 12x. So that's kind of what we've done. So 12 times x is 12x, and then 3 over x times x is just 3. I'll still divide by the coefficient of x, which is 12. So divide by 12, but it gives me a value of 3 divided by 12 is going to be a quarter, or you could write 0.25. And then this one is quite standard, very similar to the sort of ones we did earlier. I'm going to write out this 9x minus 4. I'm definitely going to be struggling for space with this one. And then 7 times x, and then 7 times 2. I think I'm going to take away 7x on both sides. Take away the 7x because I don't want x's on both sides. I just want x's on the left-hand side. So that gives me 2x minus 4 equals 14. And then it's a minus 4 there, so I'm going to add on 4 both sides, add 4 there, add 4 there. So I think I'll do myself a little wiggly line here and carry on over the other side of the line. So if I add on 4 both sides, that gives me 2x equals 18. And then divide by 2 at the end, divide by 2 at the end. The value of x is 9. Okay, so a third GCSE question. There's a bit more going on with this one, so you've got to be careful. So have a look, and we'll go through the answers just in a moment. Okay, so let's take a look. So the first part, there's in 2 parts this. So it says, Dean thinks of a number. He multiplies the number by 4 and subtracts 12. The answer he gets is 20. What number did Dean think of? Now, we could have a bit of a wild guess at this, really. But quite often, they want you to solve an equation. And in quite a lot of the questions, it will say form and solve an equation. So let's have a think. So he thinks of a number, multiplies it by 4. I think we'll use x as the number. So 4 times x. X is the number that's in Dean's brain. But then he takes away 12, and the answer he gets is 20. So we're forming the equation, and then we're gonna then solve this equation. So if we add on 12 both sides, add 12 both sides, I end up with 4x equals 32. And then we're going to divide by 4 both sides. So I'm going to do 32 divided by 4, which is going to be 8. Okay. Now we've got this question. I might need to box this 8 off, I think, because I think I will need this space, because I think the workings of this next question are going to be a little bit longer. So the packages A and B balance as shown in the diagrams below. Find the weight of package A and the weight of package B. Okay, so what have we got? So we've got A there and B, but it's got this 8 kilograms as well. We've got A and we've got 3 Bs there. Okay, so let's have a look. So part C we're doing. Okay, so we know the value of A. I'm just sort of thinking out loud here. Excuse me, just a drop of water. I know the value of A. Let me just rub out that equal sign a second. Okay, so the value of A is equal to B plus 8. So I know that much information. I know that. Okay. So the problem with this is there are 2 unknowns. Okay, there's an A and a B. But what else is going to help me out? Okay, so I also know that this B here is A is there, B is there. So 3 of these B's are equal to A. So if I do, I'll put A here again, I think. But if I swap this B for A divided by 3 plus 8. Okay, so what I've done is I've started off with this first equation saying that that A is the same as B plus 8, which I got directly from this first set of scales. But because I know that if I divide A by 3, I'll get the value of B, I sort of formed this new equation. And now I've only got one variable. So the B's are gone, I've only got A's. So what I'm going to do is I'm going to take away 8 to both sides. So I'm going to take away 8 to both sides, and that gives me A minus 8 equals A over 3. Okay. And because this is times 3, divided by 3, what I can do is times both sides by 3. Now, what I could do at this stage is introduce brackets, but I think we'll be okay with doing 8 minus 8 times 3, as long as we times it all by 3. So A times 3 is 3A, minus 8 times 3 is minus 24, and then that just leaves me with A there. Okay, we'll get there in the end. So what I want to do really is get rid of this minus 24. So I'm going to put that minus 24 back over the other side. So that gives me 3A equals A plus 24. And what I'm also going to do is take away A from both sides. Take away A. So 2A equals 24. Now, I am really running out of space, but what I can do is now divide both sides by 2. So divide by 2, divide by 2. I need to pop it on the little blue strip at the bottom of the screen, I think. The value of A is 12. Okay, so a little bit of effort. So we know A is 12 now, so we found that. I'm quite happy with that. A is 12, but we know that the value of B is a third of the value of A. So we could say B is 12 divided by 3, B is 4. So our two answers are B is 4 and A is 12. Okay, I think we'll skip over this question because I think we are getting short of time. And the reason being is I think it is definitely worth us doing this question where there's more of a shape involved. Okay, so let's take a look. So diagram below shows an equilateral triangle, ABC, with AB 4x minus 7, and it gives you the perimeter in a question of 27. You've got to find the value of x. So again, if you pause now, and then I'll come back in and we'll go through the question. Okay, so let's take a look. Now, if one side of this triangle is 4x minus 7, we know it's an equilateral triangle and every side must be the same. Okay, so I'm going to form an equation now. I'm going to do 3 times 4x minus 7, and all of that is equal to 27. Okay, now what I'm going to do is expand the brackets. 3 times 4x is 12x, and then 3 times minus 7 is minus 21, and that is equal to 27. I'm going to add on 21 both sides. So add 21 both sides. That gives me a value of 48. And then divide by 12 both sides. Divide by 12 both sides. That gives us a value of x being 4. Now, sometimes in these questions, it says substitute in x to find the size of each angle. May be pointless in this question because it is an equilateral triangle and every angle is 60 degrees. But if it was a scalene triangle or maybe an isosceles, they may ask you to substitute the value in and work out the size of each angle. But in this question, they wouldn't because, like I've said, all the angles will be 60. Okay, so the last question we'll do, I think, is going to be this one, and then we'll do a very short plenary at the end. So the diagram shows an isosceles triangle where ABC, where AB and AC are equal. All angles measured in degrees. Calculate the size of BAC. So it's asking us to find an angle. So it's asking us to find BAC, which is this angle at the top here. Excuse me. So it's this angle here. It's asking us to find. It's always worth marking that on your paper. I'll give you a second to take a look. See if you can form an equation. So pause the video and then we'll come back in and we'll go through it. Okay, so let's have a look at the question. Now, because we know it's isosceles, we know that this angle here, my pen's paying up today, this angle here just kind of shaded in, and this angle here are equal. So I can write 2x plus 30 is equal to 105 minus x. So that's my starting point. Now, same as before, I'm going to try and sort of tidy this up. So maybe I'm going to add on x both sides, add x both sides to get rid of that minus x. So 3x, add 30 equals 105, okay? And now I'm going to take away 30 both sides, take away 30. So the value of 3x is equal to 105, take away 30, which is 75. Now divide by 3, divide by 3, the value of x is 25 degrees. Now you've got to be careful in this situation because the value of x is 25. That's not the answer to the question. It would certainly get you, quite a few marks out of the 5 that are being awarded, but it wouldn't get you the full marks. So we need to work out these two bottom angles. So let's have a go. So I think x is 25. So 2x means 2 times 25. So that's going to be 50. Add 30 means this is 80 degrees. So all I did is 2 times x, 2 times 25, add the 30. But I'm just going to sort of make sure that's right because I'm going to look at this other one, 105 take away 25. Well, that also gives me 80. So that really gives me a sort of good feeling that I've done that right. Yeah, I'm happy. They're both 80. And I think I've done the right thing and the maths is okay. Now, because this is a triangle, interior angles of triangle add to 180. So if I'm finding angle BAC, I'm going to do 180, take away 80, take away 80, and the angle that I'm looking for is 20 degrees. So a little bit of shape in the space. So like I mentioned at the start, when we do solving equations, they do come up in quite a few different topics, whether it's angle related, area related, or quite a few others. Okay, so let's have a look at what we've sort of covered. So we've looked about the principle of balance, and you're probably bored with me saying whatever we do one side, we do to the other, but that is a big principle of solving linear equations. We've solved two-step equations, then we've done some with brackets, then we've done some with unknowns both sides, and then we tackled a few GCSE questions. Okay, so a little bit of a plenary just to finish off. So if we have a look at this slide, this is for a bit of sort of conceptual understanding, really. Looking at each of the scales, there's 3 separate questions. Just wondering if you can sort of create your own equation for those scales and then solve the equation. Just be aware of the balloons on the 3rd set of scales and just think, what would the balloons do to the scales? Would they push down or pull up? That's a bit of a clue to the equation you're going to form. So pause the video now and then we'll just quickly talk through those 3. Okay, so let's talk through. So the first one, the equation you're going to form, so there's 2x's one side, so it's going to be 2x plus 3, and then on the other side it's going to be 6. And then we go through our steps to solving that. We know the value of x is 1.5 or 1.5. The next one, so we've got 4x's plus 1, 2x's plus 3, so it's an unknowns both side equation. So when we go through the steps of solving that, it gives us an x value of 1. And then the last one is a bit stranger. We've got 2x, but the scale's being pulled up. So you've got to kind of imagine that as minus 5. And on the other side, it's going to be x plus 2. And again, when we go through our balance method, we're going to get an answer of x equals 7. Okay, so thank you for watching. So my next video I'll produce will be solving simultaneous equations. So a little bit of a step up on what we've done now, but certainly some of the principles that we've done today are involved in solving simultaneous equations as well. So hopefully I'll catch you for that next video and hopefully it's been helpful today. Okay, thank you very much.